Section 30 is entitled Simplifying Algebraic Expressions. First thing I want to talk about is the fact that 0 over 0 is not 1. It is not 1. Remember, for example, 6 over 2 is 3. And you can justify that by saying, well, 2 times 3 is 6. And then you say, oh, yeah, 6 divided by 2 is 3. You can't argue once this logic. 2 times 3 is 6. You can't argue that. 10 divided by 5. If you don't know what that is, you can ask yourself. 5 times 1 equals 10. 5 times 1 equals 10. 2. 10 divided by 5 is 2. Well, you may say, well, what are you saying? I don't understand. 0 times 1 is 0, isn't it? Absolutely. I mean, so fine, 0 over 0 is 1. But you know what? It's also negative 7. Because 0 times negative 7 is 0. And it's also the square root of 13. Why? Because 0 times square root of 13. Remember, 0 times any number is 0. So 0 times the square root of 13 is 0. You know what? It even equals 0. 0 times 0 is 0. It equals negative 11. 0 times any number, like negative 11. It gives you back 0. So 0 over 0 is any number. At least that's what it seems like it is. But if we allow this, we run into a lot of trouble. For example, nobody would disagree that 7 is equal to 7 times 1. In fact, it equals 7 times any other way of writing 1. As long as what goes in here is 1. As long as what goes in that box is 1. You can't argue that 7 times what's in that box equals 7. 7 times 1 is 7. Nobody's going to argue that. And of course, 0 over 0 is 1. So yes, this is 7 times 1. Yes, it really does equal 7. Okay, now remember, it's 7. This is 7 times 0 over 0. Here's 7 times, and 0 over 0 is also 9. 0 over 0 is 9. 0 over 0 is any number. So it's 1 and it's 9 in this case. And 7 times 9 is 63. Well, then we have problems. Because now we just proved that 7 equals 63. For example, if somebody owes you $7, you can say, well, gotta give me 63. Let's go. $63. They're equal. I want 63. And their hands are tied. They're like, yeah, okay, maybe I'll have the rest of the money tomorrow. Or here's your $63 now. Because they are equal. You get a 7% on the test. Go up to your teacher. No, teacher. I want 63%. Or if you owe somebody $63, you can say, okay, I have your money, and give them $7. But this is gibberish what I'm saying. It makes no sense at all. We can't have 0 over 0 equaling any number. Because when we do, then we get absurdities like 7 and 63 are equal. They're not. Someone's 7 years old, they can go down to the Social Security office and say, give me Social Security. I'm 63 years old. No, it doesn't work that way. Doesn't work that way. Somebody's 63 years old, they go to the elementary school, and they go, and like, I want to be enrolled in 2nd grade for 7-year-olds. No, it doesn't work that way. So, what we do say, and it's just a word, it doesn't matter, you need to know that 0 over 0 is nonsense. What we call it is indeterminate, because we can't determine what it is. We call it indeterminate. Call it indeterminate. Okay, so yes, one definition. Now, if I ask you what x over x equals, most of you would say 1. I learned one thing in school, x over x is 1. Well, I hope you learned something else, because it's not 1. Most times it's 1. It's 1 if x is not 0. 7 divided by 7 is 1. Negative 11 divided by negative 11 is 1. 0.12 divided by 0.12 is 1. A half divided by a half is 1. 2/3 divided by 2/3 is 1. But 0 divided by 0 is not 1. 0 divided by 0 is not 1. 0 over 0 sometimes is indeterminate. And that's what happens when x is 0. As long as the top and the bottom are the same, and they're not 0, then you get good old 1. If you have x minus 4 over x minus 4, a lot of students, after showing what I just showed, they would say, oh, I got this. It's indeterminate if x is 0, and it's 1 if x is not 0. This is not true. This is not true. When x is 0, 0 minus 4 is negative 4, and 0 minus 4 is negative 4, and negative 4 over 4, negative 4 over negative 4 is not indeterminate. It's 1. It's 1. I never once said x can't be 0. What I said was, if the top and the bottom are the same, and here they are, they're both x minus 4. I'm saying the top and the bottom cannot be 0. Okay? So the top and the bottom is the same. So most times this fraction will be 0. Now, when is the top 0? It's going to be exactly when the bottom is 0, because they're the same. And that's when x is 4. If x is 4, we all know that 4 minus 4 is 0. And 4 minus 4 is 0. And 0 over 0 is not 1. So you get 1, provided x is not 4. And you get indeterminate when x is 4. Now, just because you have variables, that doesn't mean that if the top and the bottom are the same, you're always going to have, say, indeterminate for some cases. Well, first, let me show you where you might have indeterminate in two cases. So you have x squared minus 9 over x squared minus 9. Certainly, top and bottom are the same. So this is going to be 1 most of the time. This is not all the time. So the question is, when is the top or the bottom 0? Now if you bring the 9 over as positive 9, you get x squared equals 9. Look for as many as 2 answers. X would be plus or negative 3, positive or negative 3. Okay, so if x is plus or minus 3, the top would be 0, and so will the bottom. So as long as x is not plus or minus 3, you get 1. It's indeterminate when x is plus 3 or negative 3. And here's a case where it's indeterminate for 2 values. And I can make it indeterminate for as many values as you want. For example, if the numerator is x minus 1 times x minus 2 times x minus 3 times x minus 4 times x minus 11. The bottom is exactly the same. X minus 1, x minus 2. Well, the top and the bottom, they're the same. So most times, we're going to get good old 1. And other times, we're going to get indeterminate. Well, when is the top and bottom 0? Well, if x is 1, this factor will be 0. So when I multiply 0 by the other factors, I'll get 0. The second factor is 0 when x is 2. If x is 2, the whole product, top and bottom, will be 0. I'll have 0 over 0. The third factor is 0 when x is 3. The next one when x is 4. The next one at 11. Here there are 5 values that make this indeterminate. It's indeterminate when x is 1, 2, 3, 4, or 11. It's 1 when x is not 1, 2, 3, 4, or 11. So there are cases where it can be indeterminate for exactly 11 places, or exactly 9,900 places. Now, I said that there are examples where, just because you have variables, it won't be indeterminate ever. It's indeterminate when the top and the bottom is 0. Now, I like to view numbers as being 3 different types: negative, 0, the number 0, and positive numbers. If you square a negative number, you get a positive. If you square a positive number, you get positive. If you square 0, you get 0. It is when you square a number, the least you can get is 0. And let's be honest, 0 is smaller than every positive number. So if I tell you x squared, well then I know that's at least 0. No matter what number you plug in for x, whether you plug in a negative number, a positive number, or the number 0, when you square it, the least you'll get is 0. You'll get 0, or greater than 0, which means positive. Well, if I add 9, then I'm going to be 9 or more. That is, x squared plus 9 is either equal to 9 or is greater than 9. If you're 9 or more, if you have $9 or more in your pocket, you don't have 0. There's no way you have 0. So if the least this is 9, and the least the bottom is 9, and the top and bottom are the same, this is always 1. Always 1. Okay, it'll never be 0 over 0. It'll never be indeterminate. Okay, while we're at it, let me give you 2 other cases. What if we do have 0 in the bottom? What if we do have 0 in the bottom, but we don't have 0 on top? Yeah, say 7 on top. Well, just ask yourself, 0 times what equals 7? And if you get an answer, make sure you don't get 2 or 3 answers. Because we can't get more than 1 answer. Otherwise, we get things like 7 equals 63. And the answer is nothing. Nothing. 0 times nothing. Remember, 0 times anything is 0. So 0 times nothing will give you back 7. Or 17, or 171, or negative 171. If you have 0 on the bottom, and you don't have 0 on the top, let that represent not 0. That means the top may be 2/3, it might be 11, it might be negative 93, or 0.03, even if it's 2/3. Just think about it. 0 times what will equal 2/3? Nothing. 0 times anything will give you 0. And 0 doesn't equal 2/3. 0 doesn't equal 2/3. It doesn't. We call this undefined. Those are the two cases on top now. Are the only two cases that can ever come up where you have 0 on the bottom. There's two cases where when you have 0 on the bottom. You have 0 on the top, or you don't have 0 on the top. But easy case is you don't get an answer. You don't get like 19. You get words, undefined, indeterminate. The bottom line is you can't divide by 0. And for the record, if you have 0, and say you divide by 7, well, we'll just argue it through. If you have 0 pieces of candy, and you are going to share between 7 people, I think you know that each going to get 0. And just ask yourself, 7 times what equals 0? 0. It's not 7 times 4 that equals 0. And not only does 7 times 0 equal 0, no other number would work. 7 times a non-zero number, -9, 42, 11/3, it won't give you 0. Somebody asks you, 7 times what equals 0? 0. Okay. And there's nothing special about 7. If I had 17, 17 times 0, and only 0, gives me back 0. If you have 0, and you divide it by not 0, you get back 0. You should know those three. For this section, you really need to know the top one. You must know the top one. 0 over 0 is not 0. It's not 1. It's nonsense. It's indeterminate. It's so many answers that we have to say we don't know which one it is. Now, for example, if somebody asked you to solve this. 8 times 7 over 4. And you make a mistake. You say 4 goes into 8 3 times, which is wrong. And then you say 3 times 7, and you make no more mistakes. It's 21. This is going to be wrong. If you make a mistake, it's going to be wrong. Okay? If you make a mistake, it's going to be wrong. For example, if you have this, if you have this, here's a nice simple problem. The first thing you say is, this is 1. Remember, it may not be 1. X minus 3 over x minus 3, most times it's 1, sometimes it's indeterminate. It's 1 as long as it's not 0 over 0, as long as x is not 3. It's indeterminate when x is 3. Okay, so we might be wrong calling that 1. And let's work it out. So we call it 1, and 1 times x plus 2 is x plus 2 equals 5. So all I did was cancel out the x minus 3's. And you should know that 3 plus 2 is 5. So x equals 3. But this is not 1 then. X minus 3 over x minus 3 is not 1 when x equals 3. And it will come up in the check that we're wrong. I'm going to write down the exact same problem. I'm going to write down the exact same problem. and x is 3. If x is 3, 3 minus 3 is 0. And if x is 3, 3 plus 2 is 5. So the top is 0 times 5, and the bottom is 3 minus 3, which is 0. That's the left side. 0 times 0 is 0, divided by 0. It does not equal 5. X equals 3. We have to reject. It wasn't correct. Why? Because we made a mistake. Okay? We made a mistake. You just can't cross off like factors. Okay? We were wrong when we said this was 1. We were wrong. It's only 1 when x is not 3. So, I would write in the corner, when is this not 1? 3 minus 3 makes it 0. 0 is not 1. So I would write down in the corner, x cannot be 3. That way, I don't even have to check my work. I won't even have to check it. The instant I claim I'm done, so I do everything here. I do this. I cross this out. I get x plus 2 equals 5, which is this equation right here. And I say x is 3. Then I look in my little corner here, where I keep a record of all the values that x can't be. And I say, oh, x can be 3. And I'm trying to say it is 3. So I write reject. This problem has no answer. In theory, we could have had x equals 3 and x equals 4, and I would just reject x equals 3, and the answer would be solely x equals 4. So when you cross out things, they're not always 1. Yes, 9 over 9 is always 1. But x over x is not always 1. X minus 3 over x minus 3 is not always 1. So, I think your notation should go like this. If somebody said to you, like your teacher, says, simplify this. What you should do is say, well, that's 1, provided x is not 0. So, on top of the equal sign, you should say the equal sign is only valid if x is not 0. And then put your best shot. X minus 4 over x plus 5. And that's true. This mess, including the x on top and the bottom, equals this, provided x is not 0. Provided x is not 0. So here's a question I'm going to ask for a number of problems. What value or values, if any, of the variable must be excluded? You have x plus 7 over x minus 4. Which value must be excluded? That is, for which value of x, if any, will this be nonsense? And you immediately go to the bottom. And you say the bottom is 0 when x is 4. That's the value that must be excluded. If you had 2x plus 7, and you divide by 3x minus 2, the bottom, you can't allow it to be 0. So this can't be 2. 3x can't be 2. If 3x is equal to 2, divide by 3 on both sides, you get 2/3. X equals 2/3 must be excluded, because it will make the denominator 0. The denominator is 3 times x minus 2. And if I let x be 2/3, cancels out. You get 2 minus 2, which is 0. Okay, the bottom, x cannot equal 2/3, else it makes the denominator equal to 0. And you cannot have the denominator equal to 0. Either it'll be undefined or indeterminate. But no matter what, you don't get back an intelligent answer when the denominator is 0. You have 3x minus 4 on top and x squared minus 25 in the bottom. Well, the bottom, you want to know when it equals 0. Because if you knew when it equals 0, you say, oh, those are the values I'm going to exclude. You can bring the negative 25 over to the other side of the equal sign as positive 25. Remember, there might be as many as 2 answers. There might be 2 answers, 1 answer, or no answers. If it was x to the 4th equaling 25, there might be as many as 4 answers. Okay, here, if x squared equals that number, then x will equal plus or minus the square root of that number. And I happen to know the square root of 25. That doesn't mean I'm going to drop the positive and negative sign. The answer is x is equal to plus minus 5. How many numbers does this represent? 2 numbers. This here, x equals plus minus 5. It means x is equal to plus 5 or x is equal to negative 5. Those are the 2 values that you must exclude because they'll make the denominator 0. If you have 7x minus 4 plus 3x cubed minus the square root of 7x divided by x squared plus 5x plus 6. Don't even look at the top. I never look at the top. When is a fraction nonsense? When the bottom is 0. Nonsense could mean not 0 over 0, which is undefined, or 0 over 0, which is indeterminate. You can't have 0 on the bottom. There's a record 0 over, say, 7. This is well defined. Defined to be 0. 0 is not a bad number. Ask people who are in debt. They probably have a party if they ever got their debt to be 0. That is, they don't owe anymore. That's good not to owe. So 0 is not a bad number. You buy a car and initially maybe you owe $15,000 and one day you owe 0. It's a good number. You're happy that day. Next month you don't have to make the car payment. Okay, so I want to know when the bottom is 0. This fact is, done this a few times already, to x plus 2 times x plus 3, it equals 0. If this times that equals 0, then either x plus 2 equals 0 or x plus 3 equals 0. If neither of those were 0, notice please I'm not underlining x. You see what I'm underlining. If that's not 0, and this is not 0, well then when you multiply you won't get 0. If this is 9 and this is 14, 9 times 14 is, I think, 126. But more importantly, it's not 0. Okay, so one or both of those have to be 0. Either x plus 2 is 0, which happens when x is negative 2, or x plus 3 is 0, which happens when x is negative 3. These are the values, the 2 values in this case, that you would have to exclude. That is, if somebody asks you to figure out what that is, what that equals, they better not ask you what it equals when x is negative 2 or negative 3. Because there's no answer. Can't divide by 0. So when you solve equations and you cross off x minus 2 over x minus 2, you have to be careful. You might not always be correct. Okay. Now, we're going to play this game. Fill in the box. Let's start off with some easy ones. 3 over 5 is equal to 3 over what? And I would hope the answer is obvious, over 5. 3 over 5 equals 3 over 5. 9 over 2 equals 9 over 2. 2 over 7 equals 2 over 7. If I ask you 21 over x is equal to what over x, should repeat back what I did. 21. 21 over x equals 21 over x. Now, if I give you negative 3 over 7 is equal to 3 over box. This one's a little bit different because the tops are not the same. Now, no matter what, the sign of this answer must equal the sign of that answer. I mean, if the left side was negative and the right side was positive, you can't tell me they're equal. But we are claiming they're equal. Now, if on the left, in the first box, the first big box, if the top and the bottom are both the same, that is, if we did have negative over negative, well, the right side can either be negative over negative or positive over positive. Why? Because negative over negative is positive, just like that is, and just like that is. Both sides will be positive. If, on the other hand, the left side, so if you have positive over positive, the other side can be negative over negative or positive over positive. That is, if these two are both the same, then on the other side, they both have to be the same. Because then you'll have the same sign, positive in this case. Now, if the left side has two different signs, like in our case, because the 7 happens to be understood to be positive. If you have a negative over a positive, the other side can either be exactly the same or it can be positive over negative. Why? Because this is negative, and so is this, and so is that. If the left side was not negative over positive, but rather positive over negative, the signs are different. That's negative. Positive over negative is negative. But so are these two. That is, either the signs are both the same on both sides of the equal sign, or they're both different. If the signs are the same on the left side, top to bottom, they have to be the same on the right side, from top to bottom. Now, let's see how well I'm doing in explaining this. Since these signs are different, that red plus sign wasn't given, but 7 is understood to be positive. The signs are different. Now, you can come and change the problem and put a minus there. No, 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 no. You can only write stuff in the box. So since the left side had different signs, the right side must have different signs. The top is understood to be positive. Well, then the bottom must be negative. Now, the signs are the same on both sides. That is, a negative over a positive is negative, and positive over a negative is negative. So the equal sign is coming to be true. Now ignore signs. That is, let's just deal with the numbers. This is 3 over 7. This better be 3 over 7. That is, you should put 7 there. Negative 7 is the answer. If you have negative 3 over 7 is equal to 3 over what? The final answer is negative 7. If you just ignore the signs for one moment, this is 3 over 7, and this is 3 over 7. And now we take into account the signs. These two signs are different, And yes, those two signs are different. Remember, a couple of them you can't even see. I'll put them in red. And that's the answer. If you have 15 over negative x is equal to box over x. The two signs are different. In the bottom it's understood to be negative, and the top is understood to be positive. They're different. That has to be true on the other side as well. Since there's no sign by the x, it's positive. If it's going to be different, it has to be negative on top. Okay, now ignore all signs. This is 15 over x. This should be 15 over x. That is, we have to put 15. What's in the box? Negative 15. I mean, read everything in the box. That is, the final answer is, if you have this equals box over x, where goes here is negative 15. You have negative 3 over x minus 7 is equal to 3 over what? 3 over what? Well, ignoring signs, the top is 3, the bottom is x minus 7. The top is 3, the bottom should be x minus 7. Now let's take into account the signs. There's an understood plus in front, so the signs are different. There's an understood plus sign here. For the signs to be different, that should be negative. So the final answer could be that you put negative x minus 7 in the box. Now your teacher may be picky, and it turns out that if you distribute the minus sign, you get 7 minus x. So maybe your teacher would want you to put 7 minus x in the box. But either way, those two results, they're equal. Okay? Depending upon how your teacher is about having negative signs in front of brackets in your final answer, I can't talk about that. That's between you and your teacher. Some teachers want you to simplify more than others. And as a student, you need to know what your teacher wants. So, let's reduce. Do a few reducing problems. And your equal signs have to be rigorous. They just can't be willy-nilly. Oh, when in doubt, put an equal sign. If you have this, you can factor out a 2 from the top, and you get 2 times x minus 2 times 2 is 4. So you get exactly the top. And the bottom is x minus 2. Now, since I didn't cancel out anything, those two are equal. No question about it. But now, I want to cross this out and say the answer is 2. But there's a problem there. I want to cross this out as if it's 1. X minus 2 over x minus 2 is 1. But it's not 1. This is not 1 if I have 0 over 0, if x is equal to 2. Okay, so you should write on top of the equal sign, x is not 2. So if somebody asks you, what does this equal when x is 5? You can say 2. And it is. 2 times 5 is 10. 10 minus 4 is 6. 5 minus 2 is 3. Oh, what do you know? 2. It's always 2. Except, coincidentally, when x is 2 itself. When x is 2, either you're going to, just based on what it says here, when x is 2, it'll either be indeterminate or undefined. And when you look more closely, you'll see that when you plug in 2, you'll have 4 minus 4 is 0 over 2 minus 2. You'll see that it is not undefined, but indeterminate. That's what happens when x is 2. So you just can't write it equals 2, because that's not correct. And unfortunately, at least I feel it's unfortunate, a lot of teachers would allow you to say that it just equals 2. But they're not right. If you have x squared plus 5x plus 6, and you divide this by x squared plus 7x plus 10. Well, we can factor the top, two numbers that add up to 5 for a multiply out to 6 are positive 2 and positive 3. Again, since there's an x squared and not 4x squared or negative x squared, with x squared, it'll be x followed by number times x followed by number. The two numbers should multiply out to 10, the constant. It should multiply out to the constant and add up to the number in front of x. And two numbers are multiply out to 10 and add up to 7 are 5 and 2. Positive 5 and positive 2. You may want to say, well, that cancels out. And the answer is what's left over. X plus 3 over x plus 5. But, sorry, that's not true. This is not always 1. Not when x is negative 2. Okay, so now I know exactly this is equal to this. It's equal to this, as long as x is not negative 2. So if somebody asks me, what does this equal? When x is 10, I go 13 over 15. 10 plus 3 is 13. 10 plus 5 is 15. I don't have to plug 10 in here. I could, but I'm told that it equals this, provided x is not negative 2. Provided x is not negative 2. And 10 is not negative 2. So I say, what is the top original equation equal when x is 10? You have every right to plug 10 into this, because they're equal. And for the record, when you plug negative 2 into this equation, you get negative 2 plus 3 over negative 2 plus 5, which is 1 over 3. So you're getting back to third, but you know what? You don't get a third in here. Okay, maybe when you build a bridge, you want some value in the bridge to be a third. And you, being the leading engineer, you come up with this really, really complicated equation. Took you 3 months to get, really a lot of work, and then you ask one of your workers below you, one of the workers below you, to simplify it. And they simplify it, and they get this. But they don't tell you it's not equal when x is negative 3. Now, don't ask me why. I'm not an engineer. And besides, even if I were, I kind of made up this problem. If I wanted to know when this was 1/3, if I solved this equation, I would get, that is, if I wanted to know when the original equation was 1/3, but that's too hard. I asked the person beneath me, or my coworker, whatever, it doesn't matter who they are, to find out, to simplify it and to get it to this. I'd rather solve the simpler version to equal 1/3. So we solve this, and we conclude x is -2, and I built the bridge using x equals -2. But the bridge is going to collapse because this original and most important equation did not equal 1/3 when x was -2. And somebody forgot to tell me this. Okay, somebody forgot to tell me that I can use this very easy looking equation when x is -2. Okay, so bridge collapse, etc. Your equal sign must have some validity behind it. You just can't write equal because it's the easy thing to write. You can only write an equal sign when you honestly believe. Even if you're wrong, it's not a big deal. But only if you honestly believe the two things are equal. I see students write all the time, 5 equals 7, 10 equals 18. And it's like, well, what are you doing? You know 10 doesn't equal 18. You know that. Take more pride in your work. Okay, a couple more problems. Suppose you have xy plus 2x plus 3y plus x. You want to divide this by xy plus x plus, to make this work, 3y, I think, plus 3. So you look at the top, there's absolutely nothing you can factor out. For example, this just has a number. This doesn't have any numbers. So you can't factor out anything from all 4 of them. Same goes with the bottom. This has just numbers. This or that has no numbers. So there's nothing in common. So then you say, well, you know, maybe this is the best we can do. And you're like, well, to be honest, I don't think my teacher would give me a problem where you really can't do anything. So you say, well, there's 4 terms on the top. Maybe this is a factoring by grouping. Group 2 and 2. Group 2, there's 4 on the bottom. Group 2 and group the other 2. And since there's pluses in between, there's no need to change those signs. And then you factor each of those parentheses one by one. In the top left one, you can pull out an x. And what's left over is y plus 2. Y plus 2. Plus. In the second bracket, you can pull out a 3. Remember, 6 is 3 times 2. You pull out a 3. Then what's left over is y plus 2. And in the bottom, you can pull out an x. Remember, there's a 1 by the x. 1x is the same as x. So when you put in the brackets, you just won't put y plus. You put y plus 1. Plus. In the second parentheses, you can pull out a 3. And again, it is 1 times 3. So what's left over is y plus, not blank, but 1. Y plus 1. All right. And I know we're doing this correctly because these are both y plus 2's. And after I factor out the y plus 2, I'm left with x plus 3. So that's the stuff not underlined. In the bottom, we have y plus 1 in common. Okay, and what's left over is x plus 3. And then we say that x plus 3's can cancel. And the answer won't even involve x's. The x plus 3's cancel. The final answer is just y plus 2 over y plus 1. But remember, we're crossing that out as if it's 1. But it's not always 1. 0 over 0 is not 1. X plus 3 is 0 when x is -3. we get y plus 2 over y plus 1 so long as x is not negative 3. So if I asked you, and here's the real case where this comes in handy. If I asked you, especially if you did all this work, part A is simplified, and part B says, so we did simplify, and part B says, what does this mess equal when x is 9 and y is 5? Since x is not negative 3, it's 9. I come right here. I go 5 plus 2, that's 7. 5 plus 1, that's 6. I go 7 over 6. And everyone looks at me like, boy, you're good. You're real quick. No. You're just as quick. You just need to look here. You just need to look here. No rocket scientist by coming up with 7 over 6 quickly. I just know what those symbols mean. I just know what those two horizontals mean. It means I can look here instead of at the complicated version. I can add 2 to any number real quickly. I can add 1 to that number even quicker. 7 over 6. But again, if that was part B, part A was to simplify, part B was to tell me what the original equation equals when x is 9 and y is 5. If part C says x is negative 3 and y is 4, you cannot come to the bottom, the very, very bottom, y plus 2 over y plus 1, and say, oh, y is 4, 4 plus 2 is 6, 4 plus 1 is 5. Aha, I got the answer. No. The top does not equal this when x is negative 3. And if you don't write that down, even for yourself or your coworker who's building this bridge, you're not going to know it. You're not going to remember it. I don't remember everything. But if I write it down right above the equal sign, it's fine. Now, just for the record, that's one notation that's used. Another notation would be, instead of putting x is not equal to negative 3 over the equal sign, you can write comma, x is not negative 3. That is, yep, you get y plus 2 over y plus 1, as long as x is different from negative 3. Okay, let's do one more problem. So, really being hard-nosed about your equal signs being valid, but it's very important. Suppose you have 8q times, I don't know, 3q minus 4r. And you divide this by 7 times 4r minus 3q. Now, for example, 7 minus 3 is 4. And 3 minus 7, why, that's negative 4. And negative 1. 8 minus 10, that's negative 2. 10 minus 8, that's 2. This division is negative 1. In division, if the signs are different, you get negative. There's my negative. 2 over 2 is 1. Remember, if you have a minus b over, say, b minus a, I've always said you can read the subtraction backwards as b minus a, but then you have to put a minus in the front. In the bottom, I'm not going to touch. It's b minus a. Since there's no sign in front, it's understood to be positive. This division is negative, and assuming b and a are not the same, that's 1. So the final answer is negative 1. If you write the subtraction backwards, you have one subtraction on the numerator, and you write it backwards on the denominator, It's going to be negative 1, provided it's not 0 over 0. Remember, if I have 7 minus 7 on the bottom, I write it backwards. It's first I write that 7 minus, and now I'm going to write that 7. Okay, so we have, say, 0 over negative 0. It's still 0 over 0, which is indeterminate. In other words, if A equals B, if A and B are the same, then why didn't A come up? If A and B are the same, then that's 0 on top. And if A and B are the same, then that's 0 on the bottom. But this is the same as A minus B over, well, let me not do it that way. It's the same as B minus A with a minus in front over B minus A. Negative 0 over 0. It's indeterminate. Okay? So just because you write it backwards doesn't mean, oh, it can never be indeterminate. Sure it can be. If it was 0 and you write it backwards, it's still 0. So now, if you read this backwards, it's exactly what you have on the bottom. That is, most times, this is negative 1. So you have negative 1 times 8q. You have negative 8q over 7. But the bottom or the top, doesn't matter which one I write. If this is 0, well, if that's 0, then if I multiply by negative 1, on the left side, I get this, and if I multiply the right side by negative 1, I still get 0. They're both 0. Okay? There's a number of ways of showing if one is 0, then so is the other. Well, bringing these two must be equal to one another, because the difference is 0. Now, you can solve for R or Q. If I divide the left side by 4, I'll get R. Divide the right side by 4, I'll get that. This equal sign is only valid provided R is not 3q over 4. Okay, in other words, if q is 5, then R cannot be 3 times q over 4. If R is 15 over 4, if q is 5 and R is 15 over 4, it's indeterminate. It is not this. Okay, so if I tell you, if I ask you, what does this equal when q is 7 and R is 13? If I asked you that, you really shouldn't jump on it. Well, I know that. It's negative 8 times q. Oh, q is 7. Over 7, the 7's cancel. The answer is negative 8. You have to be careful. You have to make sure that 13 is not 3 times q over 4. And it's not. It's not 21 over 4. It's a little bit more than 5. It's not 13. Okay. This finishes up section number 30 entitled Simplifying Algebraic Fractions. Good luck with it.